What this video tutorial will do is help coach you through the process of taking your standard curve data, putting it into Excel, and then generating a graph from it. So as you can see, I've already put into the two columns here, A and B, my Y and X axis respectively. So absorbance in A, I haven't put any units there necessarily because absorbance doesn't have any. It's quite exceptional as a unit that you'll deal with in this course. And concentration will have a unit of moles per liter. So I'm just going to go into my data table now, and I'm going to type in all the data that I had recorded. This is my fake data, so don't put too much stock into what the values are. Now you'll notice that all of my data points are being punched in and you have 3 decimal places. You may find yourself that as you're punching in your data, it's sort of rounding off things inappropriately. Not that you need to produce this typed up data for me, but if ever you had to, you could always toggle the number of decimal places by playing with these 2 buttons over here in Excel. So you could increase the number of decimal places or decrease them as you will. When you want to type in your concentrations, this is another matter. Most of you wrote this down in scientific notation today, which I'm quite happy about. But to type things into scientific notation in Excel, it's a little bit more cumbersome. So 0 is 0 because you didn't have anything as water, didn't have any dye in it. But for the most dilute solution that you calculated, you probably calculated 1.60 times 10 to the minus 6. Now, if you type that literally into Excel, it would not understand it. So in Excel speak, what you would need to do instead is type 1.60 and then capital E, and capital E means times 10 to the, and then you follow it up by the power that you raise that base 10 to. So in this case, minus 6. And you would type that same thing up for all of your other values, whatever they may be. All the way up to the stock solution. So great, now we've got our data set up as a table. To plot this data, what you're going to do is select all of the data. The way you could do this is by clicking in the top leftmost cell and then clicking and dragging across so that you select all of your data. Left clicking specifically if you're using a PC. You can go to Insert, and then in the chart options, you're going to choose a scatter graph. So scatter graph is typically what we do in science so that we don't introduce any biases by connecting dots needlessly. So here we go. I've got my data and we're almost set. What I want to add to this is a few elements. So if you look at the document that sent you here, what am I looking for? I'm looking for labeled axes. So I want to tell my reader what's on the y-axis, what's on the x-axis. So to do that, you're going to go to Add Chart Element, or you could even go to Quick Layout actually, and you could choose one of these layouts over here, and you'll see that it already puts in your y-axis, your x-axis, and your concentration. If you don't want something like this legend, because I only have one data set, you could just click it and press the delete button and it already erases it for you. Notice here, the axis title, you have to complete it. It's very easy. You're just going to click into it and then you can erase it, and you could type in your absorbance. And again, there's no unit for that. On your x-axis, we're going to do the same thing, concentration. And typically in a graph, we open up rounded parentheses and we put in our value, our units, in rounded parentheses. And then we're going to add a title, and a title in science could be Y versus X, sure, but I could read the Y and the X title. And so what I want to challenge you all to do is try to think of a title that's descriptive, that tells, you're trying to give the reader a sense of what is it that this data is good for? What's the story that it wants to convey? And usually it's related to one of the objectives that you're doing in this lab exercise, or something that will help lead you to figuring out the objective. So in this case, one good title might be to say what this actually is, and what you've generated here is a standard curve. So I'm going to use that as the basis of my title. And what is it a standard curve of? Well, specifically I characterize blue dye. So I'm going to add that in there. And then I'm going to add a little flair, a little specificity. So a parameter that seemed to be important when we were doing our data acquisition was the wavelength at which we did this. So if you did this at a different wavelength, your results might be different. So I'm going to add my wavelength in. I'm going to report that mine was at 630.6 nanometers. Yours might be different. It doesn't matter. And then usually if this is the first figure in your report, you could even call it figure 1. All right. The next thing we want to do is we want to actually analyze this data to see if it's any good. So unlike a titration where you're expecting the same result every time, especially like if you think to the third lab that we did where you were titrating hydrochloric acid solution with sodium hydroxide, you were expecting hopefully the same volume of base every time to neutralize that acid. But when you're looking at a tendency or a trend, there's a different way of analyzing precision. And remember, precision is how reproducible your data is. So to analyze the precision of our graph, what we're going to do is we're going to just click the dots here. We're going to go to add a chart element here on the left hand side. And we're going to scroll down to trend line. And the trend line we're going to choose is linear because Beer-Lambert law is a linear function. Now, we can see what it's done here is it hasn't just connected the dots. What it's actually done is it's gone and found the line of best fit. So there might be a little bit of variation in those absorbance values, and this is sort of the line that best connects all of the dots. Whoops. What I'm going to then do is add another chart element. So I want to really get details about that trend line. I want to know what the function is. I want to know the slope. So to do that, we're going to go to more trend line options, and then you'll see some stuff appear here on the right. And I'm going to go down to display my equation on the chart, and you can see now we have a slope, x meaning concentration, and then a y-intercept. And ideally, if your data is really good, that y-intercept is super small or really close to 0. Doesn't matter if it's negative or positive, just as long as it's close to 0, it means your data is probably pretty reliable, at least on that front. And I'm going to display the r squared on my chart. And what r squared is, it's a way of measuring how precise your data is. In short, the closer your data is to 1, the more precise it is. It's not a perfect measure of precision. Sometimes you could have really scattered data and it also gives you an r squared of 1. So you have to see, are my dots really on the line? And in this case, they are. And so I have some confidence. The thing that Excel doesn't do well is with fractional numbers like the slope that we have here. It tends to truncate it. So if you want to get a better idea of what your slope is, one way you could do it directly in the graph is click this little section where you have your slope and your regression. Right click and you can go to Format Trend Line Label. And under that you could change the category from general to number. I'm going to choose scientific because it's already in scientific notation. And then what I could do is I could play around with the number of decimal places. And that allows me to get a little bit more finesse, more details as necessary so I could highlight the significance of my data. I'm going to throw it to you and you tell me, you try to figure out what's the best number of sig figs to round this off to. Remember, your absorbance has a certain number of significant figures. Your concentration has a certain number of significant figures, and to get a slope, what you're really doing is your y-axis over your x-axis. So I'll leave it at that. Now, what I'm going to want you guys to do for your lab report is generate a full page graph to submit with your data table that you already had set up earlier. There's no need to give me the one in Excel. A really cool trick, a hack to do this, is to right click your graph when it's done and go to Move Chart. And what we're going to do is we're going to move it to a new chart. And what this will do is it actually auto-generate a full page graph for you. And when you go to print it, what you can do is go to File, choose Print, and what you're going to do is print only the active sheet. And that will guarantee you've got a full page graph to submit for me in your lab report. I hope that was helpful, and if there's any questions, don't hesitate to contact me.